Okay.
Yeah, would you like to...
Which mission do you all like the most and why?
Axis markers.
I like that one too.
Axis markers.
I like the one where he gets to the truck and it's on.
To drive it back.
Okay. Which one would you like to demonstrate for us today?
Axis markers.
I think they go to a demonstration.
I think it's unanimous.
Demonstrate they were from the table.
Since the black line. He messed up on this a few times.
No, it only messed up. It only messed up once.
He got it.
Yeah,
Sometimes it goes too far.
Yeah. Thanks a lot. But
Bob
is pretty good. He doesn't make that much mistakes compared to the other people we've
How does he know right there to turn?
Sensitive.
He's sensitive.
Like he stops right there, and he looks for the white, and then he senses the
black.
black.
It says he'll move forward a little bit when he sees white.
So he just
and
goes
then when he
straight
sees
until
black,
he
he'll
gets
stop
black again.
And then he'll keep going back and forth until he crosses that turn and gets back to
So
there.
how does he know, like, is that, how does he know he's at that point, though? Is that...
We had it tested.
Actually, we had it
in line
timed.
tracks for a certain time.
Yeah.
Oh, so it's time-based?
Yeah.
Okay. How many sensors do you guys have?
One.
Sensor,
Right.
okay. Just the light sensor right there?
Yeah.
Why don't you go ahead and describe to me why you use the different pieces you did? Yes, you got the wheels there versus tracks, you got the light sensor. Just go ahead and just go through the robot, all the pieces of it, and tell me why you use that.
The light sensor is maybe a little slower than the Dead Reckoning, but it's a little more accurate. When you do Dead Reckoning, a little misplacement could ruin the whole thing.
Okay.
And on the bumper, we also added a little peg.
Yeah, that comes
for,
around so it hits this thing.
Yeah, for the crash thing, and it doesn't interfere with that. And we put that there because we tried to ram it, and it would just slide and stuff, so we couldn't predict what would happen. So we just used that to be like more positive about it. So it wouldn't drag. We put it up a little bit, right there.
Now I see you have a little the little hand-looking thing in your hand. What mission is that for?
Gray loop.
For picking up the gray loop, and this
Alright.
is for blue loop. What we're working on right now to go
Okay.
like this.
Do you guys want to run that one for us?
Which one? Sure.
The gray loop.
No, it has to be straight up.
Yeah.
Who's your programmer?
We have four. It's Skylar, Christian, Sam, and me. Oh, we have some.
Hey, well, that's running, guys. You want to ask them about the code? Yeah. They got it.
Okay, go.
Okay, yeah. Well, that's running. Yeah. Let me ask you. When you guys were doing the design and the programming for the robot, what did you find was the hardest? Like, what was the most difficult?
Programming? Yeah, I don't know.
Holy crap.
I think the line tracker was the hardest because we had to program it. If it sees white, we had to go a certain direction. If it sees black, you had to go a certain direction.
Yep,
And we took a quite
that was
long
close. We're
time to
almost
figure out
knocked
this
over.
right here.
So you think you guys had you had the most trouble with the light sensor?
Yes.
So now I noticed that it stopped right there. What made it made it easy then to pick up the
We
what did you put there?
put a weight block.
And then right when it got there, we made it kind of adjust and then ram it in and then pull it out.
Okay. Now tell me about show me the
Driving that. The trunk.
truck.
That when it comes to it, see, it just does that when it comes to it, but when it comes back, it line tracks.
That's the only one that, but now it's
That's
not line
amazing.
track.
How does it know?
Now it line track.
Oh, I see you.
And one time we
Oh,
were
one
so
time-
close, it wiggles it and it
We can get
No, it did
lots
not.
of close
Yeah,
calls
it
of
was
this, but
like
I've
that
seen
close.
people ram 3 of those down at a time.
Okay, what's the purpose of the adding the wheel in the back?
Just to hold it up.
Okay.
So that when it hits this, it can go more straight, like be more accurate and go forward down.
Or I think it was tripod.
Tripod.
Design. And if you if you had 4 wheels, it would, like when you turn, the back 2 wheels would kind of like slide across, so it would kind of rub against it. But since we added an axle to make the wheel turn, it just follows the front 2 wheels so that it wouldn't jam.
Was that your first idea to use that, or did it come up later?
Oh,
That was, I
yeah,
think,
Later.
we
tried different types of
Yeah,
wheels.
this was-
Oh, yeah.
And that was the
when we
best.
were trying to figure out how to get over that, but we didn't get over it. But when we were trying to, we tried it with really big wheels.
Oh,
and tried
yeah.
to do it that way, and it got over. But then we would have to.
we didn't know
We'd have
when
to
it would
reprogram
stop
everything.
and start. So we
Speaking of
decided-
programming, guys, who the loops one? Now, what made you guys see? I see the pretty developed code. What made you decide to use loops or to use different things? Anybody kind of like your thought process when you were programming that?
What do you mean to like pick up the loops?
Or just say the light sensor or any of them. Just describe how you went through that inside of how to code.
Did you go through it and find that it didn't work and then kind of fix it a bit?
Sometimes
Yeah.
it used
We
to
had to
be
change
too low all the time, and it just did like that.
Knocked over.
Yeah, the
right,
claw.
and
then we had
I think a week before the competition, we kept on messing up, and we had everything right, and we didn't know what it was, and it was one little rubber piece that was sticking out, and it messed us all
And
up.
like with the back wheel, we always had to tighten it because when we were doing
Right here.
the other day, we were running it, and it was like because the back fell off. The back wheel, like the whole section fell off, and then it started dragging.
So what did you do to secure the back wheel?
We just usually just tighten it every
Yeah,
time.
every
Is that how
time
every
we push
back-
on it,
Yeah.
we check on it.
And it's kind of good that there's a space right here, because when this goes and it's in all the way, then it'll touch the back of the thing.
Now, I noticed when you're coming around here, you use your light system to get to here. How do you know the distance?
Wait, for this one,
Uh-huh.
We used lots of trial and error.
we just went straight, and when it came back, we just made it turn, and then we just made it search for the black line, and then it just starts
The
going.
truck was the first
That's
time
why
we did it.
if we mess up, sometimes if we're lucky, it just curves around like this and goes.
Here, can you guys do me a favor and have it run the code again?
What?
Which one?
Ray Roop or?
Both of them, whichever one you want first.
Okay, let's
Now it's looking.
You look at, you use light system to find your way back to home.
yes.
But what did you use you got to this point, and then you decided it's just time to go straight. How did you figure that out?
We just
We
measured
could-
how
measured
much one rotation was.
Yeah.
Yeah,
We
and
had a piece of tape on the
tape.
wheel.
So
And then we turn
That's
it.
how we measured it.
And we measured. Just see how we're running.
All right.
How about structural? One of the tests is the collision there. What did you guys do for your design to make it so that it wouldn't fall apart when it hit something? Go ahead, you're ready, Ethan.
We didn't really make anything extra. Just like
We
the
did
first
the bumper.
time we did it, it didn't knock over.
So for that
So we
one
kept
we
with the design.
added this.
Without the bumper, I think it would have less protection, and maybe the light sensor would like break or get misplaced. But since we have the bumper, it's kind of more protective than just falling apart. So
All right.
You guys want to tell us about your robot? You guys did a really good job.
What's your favorite part, or do you think your robot turned out really good?
Yeah.
I like the claw.
Well,
I like this call.
I like
So whose idea was the call?
This
Which
one
claw?
was mine idea.
This is
Can we
claw.
run
That was
the
basically
blue?
everybody.
Yeah.
Can we run the blue?
We all thought of it.
Let's do blue loop.
Yeah, go ahead.
Yeah.
That would mess up your whole job.
Yeah.
It
This one we don't
it
know if it
kinda-
messes up because we've never
That's
tried
what
it.
we have so far, but it drifts off to the side, so we need to put it at that little.
Or you
spot
could
right
just
in the
kind of
middle.
angle it so it just looks like that.
Christian, I thought you made it so it could go back.
Not
No,
yet.
not
Not
yet.
yet.
We have to lift it.
And how do you use the lift? You just know once it's a certain point, or?
We just and in case of that, I added this little feature right here, so it won't like go like that.
Right. Okay.
So make it a little longer.
Actually, that's impossible if it can go past that unless
Okay,
it
guys.
wrecks.
We're out of time. Thank you very much
Thank you
for
very much.
telling us about everything. You guys did a really good job.